Hello? Hello? Hello?
Yes, sir.
There is some disturbance. Somebody is please mute it. There is some disturbance. Please, please mute it. Okay. Now able. Hello? Can you able to hear me? Hello?
Yes, sir. We can.
Okay. Now write down the questions. Hello? Hello?
Yes, sir.
Yes, sir.
Somebody is teaching encryption. ಯಾವುದು ಇದಕ್ಕೆ Okay. Now, hello?
Yes, sir.
It's okay. We can start. Okay, write down the questions from model 4. What is the necessity of starter for a three-phase induction motor? Three-phase induction motor. Three-phase induction motor. Question mark. Okay. Explain the working of direct online starter. Direct online starter. Online starter. But it is also called as DOL starter. This is the first question. What is the necessity of starter for a three-phase induction motor? Explain the working of DOL starter. Second question. Explain the working of star delta starter. Working of star delta starter with need sketch. With need sketch. Question number 3. Explain. So write down, these are part of third assignment questions actually. Explain the working of auto transformer starter. 3 questions. There was one more starter. Which one? Can you tell me? There was one more starter.
Resistance.
Rotor resistance starter. Rotor resistance starter. So that we will discuss in speed control method, because the same starter is used as a speed control device. There we will use. Okay. Right. And 3 questions from the first chapter. These are the questions from first chapter. What is the necessity of starter for a three-phase induction motor? I will provide the material for this. Okay. PDF file is available with me, so I will post it short. Okay. Second question, explain the working of star delta starter with a need sketch. Explain the working of auto transformer starter. 3 starters. Compulsory, one question will be there. Okay. Out of these 3 questions. Fairy tale, just I will move on to the next question. Question number 4. So these 3 questions are related to starting methods. Next we have related to speed control. Next related to speed control techniques. Speed control techniques. Speed control techniques of three-phase induction motor. The questions related to speed control. Question number 4. Actually 3 methods are there. 3 methods of speed control. First one is, there are 2 approaches, stator side speed control and rotor side speed control. Stator side speed control, 2 methods. One is supply supply frequency control. Now you can write like this. Fourth question I am starting. I hope you are written on this question. Fourth question, question number 4. If this is related to speed control. Okay. This is related to speed control. Explain supply frequency and supply voltage control. Explain the supply frequency and supply voltage control. Supply voltage control for 3-phase induction motor. This is the fourth question. No problems in this chapter, only theory part. Okay. Question number 5. First chapter 5 questions are the two. Supply frequency control and supply voltage control. Only 2 methods mentioned in the syllabus. There are only 2 methods. One is the supply frequency control, supply voltage control. Last. Explain. This is from rotor side. Explain rotor resistance method of speed control of 3-phase induction. Total 3 methods mentioned in the syllabus: supply frequency control, supply voltage control, and rotor resistance control method. If you go through the syllabus, okay, these are the methods available. Okay, total 5 questions. Total 5 questions are there. So out of these 5 questions, 2 questions will be asked. 2 questions compulsory. In the model, 4th model, no numericals. So whatever you study, it's an advantage. You can attempt full question. 21. Explain supply frequency and supply voltage control, and explain rotor resistance. Even other methods are there. Total 7-8 methods are there. As per your syllabus, only 3 methods are mentioned. They are clearly mentioned: frequency control, voltage control, and rotor resistance control. Okay, we'll discuss one by one. So 5 questions total. Remember, you write down. Already I have given 3 starters: DOL starter, auto transformer starter, and one more star delta starter. And now 2 more questions. Those 3 related to starting methods. These 2 related to speed control methods. Okay. Right. If you written it, this will start. This supply frequency control. How to control the speed? Supply frequency control. Okay. Yes, supply frequency control. Supply frequency control. Supply frequency control. This is the first method of from stator side. It is from stator side. Speed control from stator side. Supply frequency control. We know what is the EMF equation of transformer. Primary, if you say 4.44 F into 5 into N1 we write, isn't it? Number of turns. Is it like this we write there? Hello? Is it okay?
Yes, sir.
Huh? Any audibility okay?
Yes, sir.
Okay, right. So based on this, because transformer and induction motors are working principle is almost same. Primary is a stator, secondary is a rotor. Even the EMF equation of transformer holds good for induction motor also. Based on that, I am writing here per phase EPH equal to 4.44 F into 5 into, instead of this N, I am writing here is a number of turns. There will not be like isn't it? T I have written here. T stands for number of turns, and we take some constant here. some constant will come here. Proportional to, if I take, if I just remove, depends on. So now, what is the flux from this? Okay, flux is equals to what? Phi is equals to, based on this, EPH divided by 4.44 F into T into K. Okay. So from this, what you can understand is this 4.44 is constant, number of turns constant, K itself is constant. So the variable are phase voltage and frequency. Phase voltage and frequency. See, the flux depends on, directly proportional to phase voltage and inversely proportional to the frequency. Directly proportional to the voltage, inversely proportional to the frequency. We know the basic formula, one of the method of that is a synchronous speed. Ns is equal to 120 F by P. In order to change the speed, we have to change the frequency. Okay, clear now? Based on this equation, the speed control is possible, to change the speed is possible either by changing the supply frequency or changing the number of poles. Whenever you want to change the frequency, there is some condition. There is some operational issue. We cannot change simply frequency. What happens? Just listen here. What happens? If I decrease the frequency, concentrate please all of you. If I decrease the frequency here, okay, if I decrease the frequency, if I want to decrease the speed, if I decrease the frequency, speed also decreases. If you decrease the frequency, what happens to the flux? Yes, what happens? Yeah, flux increases because they are inverse relations. If the flux increases, there is again, it affects the operation of induction motor. It affects the operation of induction motor. The magnetic flux gets saturated in the stator and rotor. Stator and rotor core gets saturated. Core gets saturated. The magnetic circuit will not work. Even if you increase the excitation, the magnetic flux will get affected here. If you want to reduce the speed, you are decreasing the frequency. If you decrease the frequency, what happens to the flux? Flux will increase. But this increase in flux is not permitted, not good for working of induction motor. It affects the operation of induction motor. So then what you have to do? What you have to do is, there is an option for decreasing the voltage here. Because when you decrease the voltage here, flux also decreases. Because of decreasing, this is increased. How to compensate it? How to reduce? By decreasing the voltage. This is EPH is nothing but a supply voltage. So that's why this method is called as Volts bar frequency control method. This is not called only frequency control method. It is called Volts bar frequency control. Are you getting my point? At the same time, we are decreasing both. This ratio is maintained constant such that the flux will not get disturbed. In order to maintain constant flux, we have to vary both. If we increase or decrease the flux frequency, it will affect the flux. So that's why whenever you are decreasing, you have to decrease this also. So thereby, whatever increases their flux is compensated by decreasing the voltage. When you decrease the voltage, flux also decreases. So that's why we have to vary both. That's why it is called volts bar frequency control. Voltage as well as frequency are varied, changed simultaneously. Are varied simultaneously. That's why this method is also called as what method? Volts bar frequency control. This is not possible by general approaches. Then we have to go for power electronic based control. Volts bar frequency control is based on power electronic control. I told on the previous class. So that means it will be what we are doing is the available 3-phase supply is given to the rectifier first. It is given to the rectifier. What rectifier will do? It converts the AC to DC, isn't it? Here three-phase supply we are giving, available three-phase supply. 440 volts, whatever it is there, it is a given, maybe 400 or anything, whatever it is. This is converted into DC, okay, and it is stored in the capacitors. Again, the next stage, this is called DC link. AC is converted into DC. Again, DC is converted back to variable. Here, this is the inverter. Inverter. What is the function of inverter? It converts DC to variable AC. Here we can able to change both. This is the three-phase induction motor. You will be studying this in the higher classes. This is what inverter is. This is the DC link capacitor. This is the we are changing the both voltage as well as frequency. This is possible by a technique called as pulse width modulation. This technique is pulse width modulation. We are changing both voltage as well as frequency. This technique is called as PWM technique. It is based on power electronic devices. We are making use of electronics to control the speed. In industry, this is the most widely used technique. Pulse width modulation, where we can control voltage and frequency both. Isn't it? As we are changing this, here, this is what is similar pulses are generated. Okay, here time period is also changing, voltage also changing. This indicates the voltage values. At the same time, time period is also changing. Time period is nothing but a frequency, isn't it? Time is equal to 1 by f. So that is equals to 1 by 50. 1 by 50 hertz, 1 cycle 50 hertz. It is equal to 20 milliseconds. Okay, this is a 10 milliseconds, half cycle, 5 milliseconds. So time is also varied. Time is nothing but a frequency change as well as voltage also changing. See, along with the frequency, voltage also changing. Both voltage as well as frequency is varied. In order to maintain the flux constant, thereby any desired speed can be achieved. So that is what you can call it. It is a what is a rectifier. See, this AC supply, what we have is a normal voltage. We cannot change the frequency here. But here with inverter, we can change the frequency by a technique called as pulse width modulation technique. See, if I tell you this, you won't understand. That's why I'm not telling you about that. We use a carrier wave, modulating wave. So we make use of a sine wave. Okay. And along with triangular wave like this. And we generate the pulses. We generate the pulses. Okay, by changing the width of the pulse, we can change the time. The time is nothing but a frequency. And at the same time, the magnitude of voltage is also varied. That is what we call it as a pulse width modulation technique is used here. So just if you write this enough, I think I will provide the material later. So what you have to understand here is this is the first method, how that flux is directly proportional to voltage and inversely proportional to the frequency. Okay, if you want to decrease, this will affect the flux. Flux increases. When flux increases, it affects the operation of induction motor. Flux is to be constant. So then we have to decrease voltage also. When you decrease the voltage, this flux, whatever it has increased, is now decreased. So this factor is maintained constant by maintaining V bar F constant. That's what this method is called volts bar frequency control. Any doubts in this? This is the first one, supply frequency control. Any doubts in this method? This we have to clearly explain. So if we decrease the frequency, flux will increase. When the flux increases, magnetic core gets saturated, stator and rotor core gets saturated. Then what you have to do? You have to decrease the supply voltage also. This ratio is maintained constant in order to maintain the frequency constant. How to achieve this thing? This is the technique. We have to get a variable voltage and variable frequency. This is the constant frequency supply. Whatever we have, this is the 50 hertz voltage, 50 hertz, constant voltage, constant frequency. We cannot use. Then we have to change it by using the inverter. Okay, with help of inverter, which converts DC to AC. Okay, and this AC is a variable voltage, variable frequency, using a technique called as pulse width modulation. So what is the second approach we have? Second method of speed control is supply voltage control. Supply voltage control. This is also from stator side. Supply voltage control. Here we are not talking about the frequency, only supply voltage control. So we know the running torque is given by what? S E2 square R2. Yes, E2 square R2 divided by R2 square plus SX2 whole square. This is the expression for running torque we have. So here for a lower slip region, lower operating region, your torque slip characteristic if you draw, this is the higher, this is the lower slip region in this case, Isn't it is a higher slip increasing, isn't it? It's a 0, 0, 0.2, 0.6, 0.81 like this. In this region, okay, we have this term is neglected. S62, okay, this term is there, no? Is very less than compared to R2. Where in the lower slip region in this region. Here slip value is very less, 20%, 0.2. Okay. In this region, the SX2 is neglected compared to R2 in this equation. So what you write? Torque equals to S E2 square R2 by R2 square. R2 cancels. So what is remaining? One more term here. S E2 square by R2. One R2 cancels here. Okay, one more R2 remaining. Yes, E2 square by R2. Here R2 is constant. R2 is constant. Once manufactured, it remains constant. Rotor resistance is constant. That means torque is directly proportional to S into E2 square. E2 is nothing but it is a voltage. It depends upon the voltage square. Therefore, torque is directly proportional to the slip point voltage. In order to change the torque, we have to change the voltage. Here the interesting thing. So up to here, running torque equation you know already. Okay. Next, SX2 is neglected for this lower operating regions of the slip. So you get here R2 by R2 square. See, R2, one R2 cancels. This is from R2 constant. That means torque is directly proportional to the product of slip and supply voltage. Supply voltage. Now, using this equation, I am using this equation. What is it? Torque is directly proportional to slip product and V square. Using this equation, okay. Now, if I decrease the supply voltage, what happens to the torque? If I decrease the supply voltage, what happens to the torque?
Increases, sir.
See, this is a direct relation.
Yes, sir.
What happens? Torque decreases. Because direct relation means whatever it happens, even the same thing happens with the switch, isn't it? So when voltage is decreased, supply voltage is decreased, torque also decreases. But decrease in torque is not advisable because it has to take the load. Okay, the torque should be almost, it has to maintain the constant torque. It has to take the required load on the motor. If torque has to be maintained constant, we have decreased the voltage. When you decrease the voltage, torque decreased. When torque decreased, it is not advisable. We don't want to decrease the torque. We have to maintain the same torque. Then what you have to do? We have to increase the slip. Slip will increase automatically. In order to maintain the motor, its load constant, whatever the load is on that, to maintain the load constant, slip will increase. Slip increases means what does it mean? Ns minus n by ns, isn't it? So that means when slip increases, this is a constant. It is constant, 1500, let us say, example. Now, when slip is increasing means what? This difference will increase. In this difference is increasing means first it is maybe running at 1400 RPM. Now, if slip increases means what is happening is it is now running at 1000 RPM. You observe the difference now. 1500 minus 1400. 100 difference is there. Here, what is the difference? Now, what is the difference? When it is running at 1400, difference is 100 RPM. When it is running at 1000 RPM, what is the difference? 400. So when this difference is increasing, slip also increases. What does it mean? When slip increases means motor is running at lower speeds. Motor is running at, it is decreasing its speed in order to supply required torque. Okay, when you want to decrease the speed, you have to decrease the voltage. Slip will increase. Slip will increase because torque has to be maintained constant. In order to maintain the torque constant, slip motor automatically decreases its speed by increasing the slip. When slip increases means the rotor speed has to be decreased because this is constant, nothing to do that. This difference increases means slip also increases. So 1500 minus 1000. Now the motor is running at 1000 rpm. So what is the difference? 400. The difference is increasing means slip also increases. So this method, a small change in speed, we have to very large voltage. This is not a suitable method. In order to change a small change in speed of motor, where the large voltage has to be changed. It is not advisable approach. Okay, this method is not used. This is the one of the approaches. Okay? It is available, but you have to explain. This is the voltage control method. It's clear now? This you have to explain like this. Torque is directly proportional to S into V square. When you decrease the voltage, torque also decreases. In order to maintain the same torque, this product, it has to increase. Okay? To maintain the torque constant, slip has to increase. Slip increases means speed decreases. So there is a variation in the speed of the motor. Just condition. Any doubts with this? Totally different. That is V bar F frequency control is different and this is different. Supply voltage control it is. Okay. But as per syllabus, only these two methods are there. But even there are other two methods also. From stator side we can control. Number of poles also we can change. Number of poles also we can change. That's the one approach. Because you know that Ns is equal to 120 F by P. P is inversely proportional to the number of poles. Then increase the number of poles, P decrease like this. So there is a number of poles also we can change. How to change number of poles? That is a third method of stator winding, and that method is called as, we have changing the number of stator poles. There is a method called as third one, changing the number of stator poles. Stator pole. This is the two windings here. Two stator windings. Two windings. One will have 4 poles and another will have 8 poles. Okay. So there will be a changeover switch. Using the switching technique, you can include either 4-pole winding or 8-pole winding. So you know that Ns is equals to 120 F by P. This is equals to 120 frequency constant. How many poles are there? 4 poles. 4 poles means 1500 rpm. If it is 8 poles, Ns is equals to 120 F by P. That's again 120 into 50 by 8 poles. What will be the speed? Half of this? 750? 750 rpm. See, we will have a 2 speeds. Depending upon your speed requirement, number of poles are included. 2 windings are required. The drawback of this method is 2 windings. This 2 windings are required. And continuous speed control is not possible. Second disadvantage. If you want to vary the speed like 100 rpm, 200 rpm, 300 rpm, not possible. Fixed speed control is possible. Either you run at 1500 or run at 750. And see that additional windings, it increases the complexity of construction. Okay? Additional windings are required. Cost increases. Okay? This is not a suitable approach also. Changing the number of poles is also not a suitable method. Only the first method is used practically. That is the problem of induction motor. It is unlike DC motor. DC motors are many techniques are there. But in DC, controlling factors in the induction motor is only frequency or voltage. Okay? And that volts bar frequency method is most widely used technique. So this is one changing the number of stator poles. So the fixed poles will be there, 4 pole or 8 pole. Okay, changing the switch to 4 pole, speed increases. Changing to 8 pole, and it is a inverse related. See, when the number of poles increases, speed decreases. Only 2 speeds. In between, no other speeds are possible. And this is applicable only for SCM, squirrel case induction motor. This technique is applicable only for SCIM, squirrel case induction motor, not for slipping. This is the third method of changing the number of stator poles. Test it. And one more technique is that including the resistance in the stator winding, like this. Including the resistance in the stator winding. This is another approach available, but it is also not. Okay, this is given to the stator winding. It is given to the stator. It is starter. This is called a stator, and there will be rotor also. Nothing to do with the rotor. This is the rotor, and this is the stator. Before supply is given to the stator winding, a variable resistor are connected. This is the supply. What is it? So here voltage drop takes place here itself. 400 volts if you apply, 100 volts it is dropped here, only 300 it is getting. That very simple technique, a variable resistance is included in the stator circuit. Thereby, if you increase the resistance, voltage drop, more voltage drop occurs here. So the motor will get less voltage. When voltage decreases, speed also decreases. Here also lot of power is wasted here in this case because of resistance. I square R losses are significant. So this is also not a suitable approach. This is one of the method of the including a variable resistance in the stator circuit. So we have this is one of the approach not mentioned in the syllabus. That's why I'm not going into it. Only first two techniques we have to study. And third one we have from rotor side. Rotor side. It acts as a starter as well as speed control. Rotor side. What is it? Rotor resistance. This is also there in the syllabus. Three methods. Two from stator side, one from rotor side. Rotor resistance method of speed control. Rotor resistance method of speed control. So what we are doing here is, in this method, a star connected rotor terminals are taken and it is connected to the slip rings, 3 insulated slip rings which are fixed on the shaft. This is the slip rings, 3 insulated slip rings are there, okay, and externally they are connected to the variable rheostat, and these slip rings are rotating along with the shaft. This is the slip rings, they are fixed on the shaft. This is called as these are the brushes. They are externally connected to the variable resistance, like this. They are connected to the this is the rheostats, variable resistance, external resistance connected inside. Stator will be, this is the stator is nothing to do with the stator. Stator will be there, okay? With the stator, let us stator it is, and rotor. Here we are adding extra resistance in series with the rotor with help of slip rings and as well as brush. Brushes are not rotating, they are fixed, okay? Because in order to have a connection, this is the rotating part, it is a stationary part. Brushes are making contact, mechanical contact will be there. So current enters here like this, okay? And connected to the rotor resistance. R2 is already there, rotor resistance. We are adding extra resistor in series with the rotor, starting resistor. Now total resistance increases, which helps to increase the starting torque also. And this is only applicable for slip ring. not for squirrel cage, slip ring induction motor. This technique is used for slip ring induction motor. So how it works? How it works? So here first we have to put this resistors at maximum resistance position. Maximum resistance position. At the time of starting, we have to put maximum resistance position. Now we are applying the 400 volts to the stator. 400 volts you are applying. Okay, flux is induced in the rotor side. Rotor current is minimum because it is high resistance is included in the circuit. The rotor resistance is very less, but we have included full resistance, let us say 100 ohm. But what is the resistance of rotor? Normally it will be in terms of 2 ohms. Very less resistance, rotor resistance. And we are adding now 100 ohms. Full resistance is added here. So it is not allowing any current in the rotor circuit. Now the rotor current is very less because of this high resistance is added. Now slowly decrease the resistance. Slowly decrease the resistance. When you decrease the resistance, what happens? Rotor current start increasing. Rotor current starts increasing. When the rotor current start increasing, it starts rotating. It starts rotating with high torque. With high torque, it starts rotating. Okay, so like this. But the rotor current depends on stator current. Okay, when the rotor current increases, I1 depends on I2. I1 depends on I2. I1 depends on I2. Clear? When the rotor current increases, stator current also increases, supply current increases. It takes more current from the supply. More current means you have to apply more voltage. Voltage is increased to this rotor side. Clear? So this is the one technique available. It is used as a starter as well as speed control. Okay. When you are putting this at maximum resistance, speed is less. As you decreasing this resistance, rotor current increases. When the rotor current increases, speed also increases. Okay. Depending upon the rotor, the stator will act. If the current increases, it supplies more current. If the current is less, current supplied by the stator is also less. Okay. I1 depends on I2. Depending upon the rotor current, the current in the stator is changing. So this is the one method is available. As I told you, lot of I square R losses taking place. It's also not a suitable approach. Loss efficiency decreases. When the losses increases, efficiency decreases. Rotor losses are more. So when the losses are increases, efficiency decreases. So that's why this is also not suitable method. Clear. But three methods we have to study. One is a supply frequency control method, voltage control method, and rotor resistance control method. Okay. And we know that again, as you know, the torque is directly inversely proportional to the rotor resistance. By varying this rotor resistance, by adding extra resistance, we can control the torque. Torque is nothing but again this speed variation. So based on this equation, rotor resistance inversely proportional to the torque. Any doubts with this? So three techniques I told you. Speed control of induction motor by stator side and rotor side. Even two more techniques are there from rotor side. I'm not going to discuss about all those things. As per syllabus, only three techniques are there. Stator side two techniques, rotor side one technique. This is the one technique only. Rotor resistance control method. Okay. Initially it is kept at high resistance. Current will be less. It runs at low speed. You decrease the resistance, current increases. It start increasing the speed. That's all. Any speed can be achieved. Okay. Any doubts if you have, you can ask me. So that ninth was my examination, IA test, isn't it? Motors was on 9th. It is postponed
Yes,
to 12th because of that vaccination. So make use of that advantage of vaccination. Okay, may become mandatory in future if you want to attend for labs, if you want to attend for examination, if you attend for classes, that certificate will be mandatory. So all of you come and make use of that. When you have that. It is on 9th, no, Friday. Drive is there, vaccination drive. Come and have it. It's better. We have already taken, no problem. They have to wait for another 2.5 months for the second dose. First dose, if you are not taken, please make use of that. It's very difficult. Again, see, now earlier people were not taking the vaccination. Now they are eager to take. A lot of competition there. You will not get opportunity. Even outside is also very difficult to get that Covishield vaccination. So that's why my advice is all of you come and make use of that. Clear? And it's very just 1 second they finish it. It's very simple and nothing will happen also. And it's very good. Again, second dose will take time. It will take around 60% protection you will have. The safer side. So all of you, second dose above 95% protection you have second dose. Okay, wind up now. This is the first chapter. I'm concluding now, and continue the second chapter in the next class. After interviews. If you are not having any doubts, I'll wind up now.